Let's talk about classes and object-oriented programming. This lecture comes from my book, Computer Scripting Techniques with Python, Chapter 17. Let's scroll down and take a look at the learning objectives. State the purpose of classes. Use unified modeling language class diagrams to communicate application design. Use the class keyword to define classes. State the purpose of the underscore underscore new and underscore underscore init special methods. Explain what it means to create an instance of a class. State the purpose of the self attribute. State the difference between functions and methods. Create instance variables. Define methods using the def keyword. Call instance methods using dot notation. Define properties using the @property decorator, and define property setters. I might put properties in another video, but anyway, let's get going. Classes are not hard to understand. If you understand functions, you should read the chapter Modules and Functions, which I believe is in chapter 12. Okay, so read chapter 12 before you read this chapter. Classes are a foundational concept in object-oriented analysis, design, and programming. They allow you to gain a clear mental understanding of how your code is organized and structured, leading to clean application architectures. Clean application architectures lead to code that's easier to manage, maintain, and evolve. Now, I'm not talking... look, there's a debate on whether or not... I use the term clean, not necessarily in the term clean code, but structurally, when I look at a project, I like to be able to identify, right? Like, what are the major components by just looking at the class, the classes that are part of that project source code, okay? Anyway, we'll get into that. Classes along with code modules. Well, let me see. Classes enable you to co-locate data along with methods, right? So classes enable you to group the data and the methods that operate on that data in a logical location, okay? Classes required to process that data in a single coherent user-defined data type, right? Which is what I just said. Designing an application with classes allows you to think in terms of objects and the interactions between them. And this change in thinking helps you to tame conceptual complexity. That's really the key right there. Conceptual complexity. If you just have an application made up with a bunch of modules, and then each module defines a boatload of functions, you know, it can be kind of challenging to figure out how those things go together, but classes goes a long ways towards making that better. Now, not just willy-nilly, right? Like if you just use classes, your code does not become magically more conceptually easier to understand. In fact, if you just use classes without any architectural design thought behind it, then probably the opposite becomes true. You could really muddle the waters if you don't use class naming concepts and you know, just like methods and functions, classes should pay attention to what they're doing and not do a bunch of other stuff that doesn't belong in the class, right? So you want to maximize cohesion, right? You want to minimize coupling in the same way in a class as you do with a function and methods, all right? Now, classes along with code modules allow you to tame physical complexity as well. Physical complexity refers to the number of source files and other artifacts a project contains. And as a general rule, the bigger the application, right, the greater the physical complexity. And so if you break your project into classes, it helps you tame that physical complexity. In this chapter, you'll learn how to define and use classes in your programs, and I will show you how to visualize classes and their relationships between each other with the help of Unified Modeling Language, which is a standardized modeling language used in software engineering to design, model, and document software systems. It's a meta language, and I'm not going to go too deep into UML, but you don't see a lot of you don't see a lot of people talk about unified modeling language. But when I'm in the classroom, I like to communicate what I'm doing design-wise, not just in the classroom. Like in my professional life, I deal with other software engineers. If we're on a Zoom call, we pull up a whiteboard, or if we're in person, we get to a whiteboard, right? And we write the rectangle that represents a class and its relationship to other components within the system that we're designing. And we can communicate our design ideas that way, right? Now, what is a class? In the world of software engineering, the term class has several meanings depending upon the context in which it appears, of which we are concerned with object-oriented analysis, object-oriented design, and object-oriented programming. Okay? So I will treat object-oriented analysis and design as one context, as the lines between the tasks performed within these two activities are often blurred. Okay? In the context of object-oriented analysis and design, a class is used to represent the concept or notion of an entity within a problem domain. There is usually a one-to-one mapping from real-world objects in the problem domain to classes within the design domain. Okay, so in other words, what you're doing is, like, let's say you're trying to build a system, or you're working on a big complex project, and you sit down and you figure out, like, what am I going to build? How am I going to represent this thing in the real world in a computer program? Well, you start just doing your analysis and figuring out what is your system comprised of? Is it there's people that interact with the system? The system has to process data. What types of data does the system process? Does it interact with things? Does it, et cetera, right? This book is not a book on object analysis, design, and programming per se, right? You have software engineering courses that are devoted to that sort of stuff, right? But you have to know a little bit about what you're doing in order to understand the role that classes play, okay? So in the context of analysis and design, you've got a problem that you're trying to model and create a design for. So a class represents a real-world object in the problem domain to classes within the design domain. Now, following the problem domain analysis, an initial software design is created which attempts to identify the properties and methods required by each class. Such a design is visually expressed with unified modeling language, class diagrams. Okay, and we'll talk about this later in the chapter. Now, the activities, right, are performed iteratively, so you don't just sit down and everything just comes up at once. You look at the problem, work on it, come up with a design, discuss that amongst your peers or yourself, go back, do another iteration, and eventually you will focus in on, what the design should be. It may not be perfect, right? But you can't change something unless you have something to change. Now, in the context of object-oriented programming, a class refers to a programming language construct that enables a programmer to implement in code the conceptual notion of a class as discovered during analysis and design, right? So we can talk in terms of classes as analysis in the analysis and design phase. And then when it comes to programming, the language has to be able to enable the implementation of such a thing, okay, when Python does that. Now, different languages, right, do object-oriented programming differently. Python does not understand the concept of encapsulation, except for the notion of underlining, prefixing underscore to a variable name if you intend to keep that variable or that method or that function private, right? There is no notion of privacy. There is no notion of encapsulation and data hiding done by the language itself, right? Just because you put an underscore underneath in front of a method or a variable, an instance variable, does not mean that you cannot access that. Okay, so Python is a little, you just have to be leery of what you're doing with Python. But personally speaking, once I got the hang of Python object-oriented programming, I never had any problems. with how I was using classes and defining classes and using them in my programs, right? Okay, a class definition can specify what type of data an object can contain and what type of behavior an object can support, or both. And usually it's both. Okay, usually it's both. So we'll see this in a second. Now, what is an object? A class is used to create one or more objects within your program. A class definition is just that. It's a definition. To actually do something with the class, you must create an instance of the class. You will also hear and see related terms such as object instantiation. This results in an object of the class type being instantiated or created in memory. An object is nothing more than an area in memory that contains the data associated with a particular instance. Okay. Now, how do you define a class? Okay. So let's say you're working on a program that needs to represent the concept of a person with a few basic attributes like first name, middle name, and last name. So example 17.1 gives the definition of a person class. Now, in this particular example, let me pull this up in Visual Studio Code, right? Nothing worse than looking at source code in a book. So give me 1 second. I need to switch to my iTerm. All right. I'll go ahead. So let me go ahead and pull that up and I'll be right back with you. Okay. So I've got the person class as shown in the book here. Let me pull the book back up. So we've got, okay, so we have the class person. Okay. And then we have a class-wide attribute. Okay, so let me go to Visual Studio Code. All right, so that's the same one we're looking at. All right, so we've got to define a class. So first off, let's take a look at some of the administration. Just because you're creating a class doesn't mean you have to lose your mind with module naming. So the way that you name your module is what you're going to have. Whatever class you define in the module, name the module the same name as the class, but lowercase. If the class has multiple syllables or multiple words that you want to separate the module names by underscores. Like, for example, so like person, okay? Anyway, when I show you the example, I'll draw your attention to the module naming. But here we have we have a module named person, all lowercase for modules, .py. So person is the name of the module. And then in this module, we have a class definition. We find the class definition. And this is how you tame conceptual and physical complexity, right? Because if you have a big project, I can pull up a big project. In fact, let me pull up a big project and I'll show you what I mean by taming conceptual complexity, okay? So again, I'm going to open up a new window because I'm going to go to, this is some stuff I do for work, right? So here I am in the terminal. So I'm going to say change directory to dev. Okay, so dir cd fractal, dir cd dev.fractal. All right, so let me see. FADS ICCP. I'll go to FADS ICCP. FADS underscore ICCP. CD FADS ICCP. And then code dot. All right, so here I have a project. I'll keep it the text kind of small here, but let me stretch that out a little bit. I'm going to close this. That's my environment. This is my SQL. In fact, I was working on some of this stuff today. Okay, so I have my project structure have a configuration file. I have a database folder with all the database creation scripts, etc., etc. Distribution, I have a distribution directory, which is when I build the project, it puts the wheel file in there. Logs, I have a logging directory, and I have a source directory. I got tests, but let's go to source. Now, source, I use something that I don't cover in this book, PDM, Python Distribution Management. PDM, I think, is the name of the tool. And anyway, and when I initialize the project folder, it creates this structure and puts the name of the project, another folder called FADS ICP here. Now, here are my subdirectories. All right, so I've got in my source, I have this folder FADS ICCP. I have an API. This project is for a fast API REST application, so a web app, right, with the REST endpoints. And the API is where I store the models, right? See how things are organized? The routes, the settings, all right? And then in infrastructure, I've got dispatch command. So see how the naming there, right? I just want to kind of bring your attention. So dispatch underscore command underscore, and VO stands for value object, right? That's my holdover days from my Java programming days. And then, so dispatch command VO, and then the name of the class is capital dispatch, capital C command, and then VO for value object. I have a folder for JSON encoders. So I have an encoder called JSON underscore datetime underscore encoder. That's my module name. And then the class name is JSON datetime encoder. Okay. Logging. I have a logging service. So that's my module name. My class name is logging service. Notifiers. SNS notifier for simple notification service in AWS. That's my module name. Here's my class name, SNS notifier. So I just wanted to show you, like, here are module names that have multiple words in them. Dispatch command VO or JSON datetime encoder. That's the way the modules look. And the class name is, no spaces, no whatever, right? It's just the word. And that's really what I wanted to show you here. So I'm going to close this part down. Now back to this class. Now, so we have the module name, okay? And we have the class name. So the class keyword is used to define the type. So we're defining a new type. We're going to say class type. Now, really, this is a namespace. So the class person, is simply a namespace that has all this stuff defined in it. Now, all this stuff isn't much at this point, but it's quite powerful, right? So we have initially, for this person class, we've created, this is actually this is the constructor. This special method, I know there's no spaces here, right? But this is underscore underscore new. I got to really change my font. So def underscore underscore new, and then for this particular, for the constructor, okay, now this is going to be confusing because in a lot of Python text, the constructor, people will refer to the initialize method as the constructor. That's the initializer. A constructor's job is to create the object in memory, and that's what the new does. The underscore underscore new creates a new person object in memory. And then if debug, I have new method called, okay? And then you create an instance of super new and return the instance. And then once you've created the new object, then you can call the initializer on that object. Now, for the most part, unless you really have a good reason to implement new, and I only did it in this case for this example for demonstration purposes, you don't have to do underscore underscore new. You don't have to implement the new method, right? So, and I'll show you how this runs, and then once I get done reviewing it. So then we come to the initializer. This is the initializer, and it takes a self. Now this could be anything. It could be you, me, they, right? But self is the pretty much the de facto standard word that you use here. And this is just a name that refers to the instance object. because here is where you're going to be able to then get a hold of the instance variables, like anything that you define up in here in the initializer. Then you can access those from the self, right? But except for the constructor, which, like I said again, you do not usually have to implement except under extraordinary circumstances. You will generally have an init double underscore a special method. These are special methods. All these are special methods. An init a function, and it takes self as the first argument always. And then if there's any other parameters you want to feed when you initialize the object, okay, like for example, first name, which should be a string, that's a type hint, equals John. These are all default values. Middle name, which is a string, J, and last name, string, Doe, right? So all these parameters are optional because they have default values. And it initializes a person object into a known state. So we're creating 3 instance variables here, or instance attributes is a correct term. You can say instance variables too. So self.firstName, right, equals first name. Self.middlename equals middle name, which is the name of the parameter that's coming in. And then self.lastName, which is last name coming in, right? And then I increment person.count. Now person.count is defined up here, and because it's outside of anything and doesn't have a self in front of it, it's part of the person class. Now, then I print a debug, right? Init method called person object initialized. And now the string, the underscore str is a string, returns a string representation. So when I feed a person object to a formatted string, let's say, okay, an F string, then this is what happens. This will do, if you don't implement these, let's say that you leave that out, then it's going to return, then the default behavior provided by the object, okay, and that's something that I did not specifically say, like class person, it extends automatically the base object that's available in Python, right? You don't have to explicitly say that. But object provides a default implementation for underscore string. And in the book, I think I demonstrate the effects of not implementing a string representation, or the special method double underscore str underscore, right? So anyway, here's what happens. This is what it means to be a person and represent itself as a string. It returns self first name space self middle name space self last name. So let's run this. Here's what main does. How do you use this person object, the class? So first off, you have to import the class from the module it's defined in. And then here in this main function, I said P1 equals person. And I can do that because although first name, middle name, and last name have default values. So then I can say P1, print P1 equals P1. And because P1 has a string representation, P1, this will actually call this function, this method here automatically and say, because that P1 was initialized with these default values, it'll say John J. Doe, right? So let's just run this, and then I'll go through that. Okay, so let me go to the console. Let me get rid of this small one and clear the screen, dir, and then go into person project, person underscore project. CD, CD. Losing my mind. CLS. Okay, so I'm in person project, and then I'm going to run Python main.py. So when we create the instance of the object, like P1 equals person, the new method gets called, and then the init method gets called. And then we see P1 equals John J. Doe, and the object count is 1. Then I create another one. Let's go to the code. I'll create another one in the main. So here we have P2 equals person Rick W. Miller. And then I say P2 equals P2, and then I print the object count. So let's take a look what that looks like. So here, so whenever I create the new person, the new method gets called. This is the constructor. This is the initializer. Okay. And then object count equals 2. This is a class wide, right? So that's keeping track of how many objects are created. And then one more time, I create another one. New gets the initializer, the constructor gets called, the initializer gets called, and I call that one Hannah J Banana, and the object count is 3. Okay, so let's go back to the book. That's what this example is just giving you. Now, again, you can refer to the PEP 8 style guide, and I'll go to this link here and pull over the resulting web page. Give me 1 second. Let me make it the right size. Okay. So PEP 8 style guide, right? This is where you see, like, how do you name your classes, like naming conventions, right? Like, if I'm doing something in the code, it's usually because the PEP 8 style guide says that's what should be done. Okay, so enough of that style guide stuff. All right, so that I think, yeah, okay. So I went through the main. I show you how to instantiate objects. So this is once again, this is called instantiating an object or creating an instance. Let's go back to Visual Studio Code. The person class defines a person class. It's like a stamp. It's like a template. I hate to use the word template because templating is used in there is a thing called templating, right? But kind of like a mold, right? These are tropes, right? Like it is the blueprint, also a word that's overused, right? That specifies, like, when I create a person object in memory, this is how it's going to be, right? And then once you've got this plan that allows you to create these person objects, then you create instances of these person objects, and these are actual objects in memory, right? Whereas the person class is just code in memory someplace, right? This exists as code. These exist as objects, and the objects are associated with the data for each one, right? So when I set person, in this one, the first name of the person is John for the P1, right? Because I use the default parameters. In the P2 object, the first name is Rick. In the P3, I'm demonstrating here how I can actually access those object or those instance variables directly. So I create the object. Initially it starts off with John J. Doe, and then I go P3.first name equals Hannah, P3.middle name equals J, and P3 last name equals Banana. All right. And this technically, this drives Java programmers and C# programmers and C++ programmers nuts. But this is technically like the way you'd want to do Python classes, right? If you have these properties, just leave them open, right? There is a property keyword, and I'll go over that in another video because this one's getting a little bit long. Anyway, that is an introduction to classes. So we've covered the naming, the rationale for classes. They help you organize your code. They tame physical and conceptual complexity. The term class is used in analysis and design. And then, of course, in the language itself, you have a keyword. You have to have the language enable you to create a class, right? And then once you create a class, you define what it does. In this case, the only thing this class does is allows you to create instances of the class. and set the first name, middle name, and last name, because it's got first name, middle name, and last name attributes that you can mess with. Now, the thing about Python is you can add attributes to a class willy-nilly, right? So, but a disciplined programmer will not do that, right? So that's another kind of strike against Python in my term, and why I like languages like C++, C#, and Java, because they don't allow that kind of stuff, right? But anyway, that's class. Introduction to classes. I hope you found this helpful, and I will continue with other facets of classes in following videos.